So welcome everyone to this webinar on the new ChemSec report, What Goes Around, regarding chemicals in recycled material and the potential financial benefits of a toxic-free circular economy. So if you have any questions, please write them down in the Q&A section in Zoom. And for your information, all the slides and the recordings will be made available after the webinar. So Peter, you can start with the first slide, please. Great. I'll start with a brief introduction of our organization. So ChemSec, we are an environmental NGO aiming to reduce the use of hazardous substances by cooperating with companies, highlighting good examples, opportunities, being a positive voice, really. And we have constructive discussions with policymakers, looking for solutions that are not only beneficial for human health and the environment, but also good for companies. So our focus is on chemicals, but these last few years, much of the political debate has been held under the circular economy umbrella. Our funding comes from governments and charity foundations, which enables us to keep our integrity when boosting what some companies do. So we gain no money by doing that. We collaborate and we help companies with phasing out hazardous chemicals, but we also work with investors, providing them with analytical tools to evaluate and reduce investments related to toxic chemicals. So we do all this even though the EU regulation on chemicals is the most stringent in the world. It's not enough. Doesn't adequately protect human health and the environment, and it needs to be improved. And this is especially relevant when taking on the circular view, where all materials should be recyclable, sustainable, future-proof, really. So the current regulations are not enough, and it doesn't provide for non-toxic material cycles. And that's why we're all in trouble now when the pressure is on to increase the use of recycled materials. And progressive brands, they've been working on this for a long time. You can switch the slides, please. So to gain insight and understanding on the challenges that companies face, we speak to companies every day to learn more about their experiences. And at the core of this cooperation is our ChemSec business group, which you see on the slide. It consists of companies that are front runners. They come from many different areas, but they tend to face the same issues very often. So this makes the conversations very interesting. You can switch slides, please. So one of the things that we do for companies is that we provide a number of online tools, which are really much more known than our ChemSec name. And the one that has had the biggest impact is the SIN list. It's a list of very problematic substances that brands should substitute when possible. It's used by brands globally and features groups of chemicals such as phthalates, endocrine disruptors, and perfluorinated substances. All of these also highly relevant for recycled material. We have Marketplace, where chemical producers of alternatives to hazardous substances can promote and get in contact with brands, and vice versa, all aiming to reduce the use of hazardous substances. In ChemScore, we evaluate the 35 biggest chemical producers, and we rank them according to their performance regarding substitution, production of toxic chemicals, and some other criteria. So please have a look at these and the other tools and initiatives available on our website. So back to how this links to circularity. Yeah, you can take that slide, thank you. The Commission has been clear in its aim to implement a circular economy. So ambitious goals, it's something that we've also seen from many brands. And when we discuss the aim to increase the use of recycled materials in products with brands, it's become clear to us that it can be highly problematic as they need to ensure that the functionality and the content is up to standard. And this is why we've decided to dig a little deeper and provide a report that gives better overview of the issues and opportunities. And with that, I'd like to hand over to Anna to take you through the report.
Thank you very much, Teresa. Yes, what I will do is more or less to give an introduction to the issue of hazardous chemicals in a circular economy. I'm using the report as a base, so it's also possible for you to go in and download that one for free and have a further read if needed, or if you want to. We can take the next slide. So the idea of something called a circular economy has been around since the 1670s, although it has been called different things through the times. The whole aim or with this concept is that we want to design out waste and pollution. And to do that, it's needed to keep products and materials in use for a longer time. And if we do that, we can also regenerate the natural systems that we are currently depleting of the resources. And what we have today is also sometimes called a linear economy. It means that we take materials from the environment, natural resources, we make products, and then we waste them. And what we want to do instead is really to close the loop. So using instead resources already within the system and using then the waste as resources, basically. And there are many different actions needed to move towards a circular economy, and that are also part of that concept. For example, to reduce what we put into the system, to reuse what we have there, repurpose, use things for different purposes than it was meant for, to prolong the lifetime by mending and maintaining and so forth. But in the end, things will become waste in our view, and will then be needed to be recycled and put into new production. And so recycling is key, of course, in closing the loop. And that is also where we see the issue of hazardous chemicals as a main problematic. And so much of the report and the talk today will also focus on that part, on recycling and recycled materials. So we can take the next slide. And so even if we have tried to recycle materials for a long time, there is still a long way to go. An index called Circular Material Use shows that in 2019, about 12% of materials in the EU was circular in some way. And the Circular Economy Action Plan that Teresa mentioned, put out by the European Commission, has set up high targets. One such is to double this number in 10 years. So we have quite a long way to go. We can take the next slide. And why are chemicals important in this matter? Well, first I want to say, to avoid any misunderstandings, that everything is made from chemicals, of course. Everything consists of chemicals, and we don't want a world without chemicals that cannot exist. But what we are talking about are the man-made chemicals, the chemicals that we introduce into the system. And today, this is a report from the European Environment Agency that shows that today we have more than 100,000 chemicals on the market, whereof very few are characterized as to their properties or hazardous properties. And we also know that the production of chemicals steadily increase. Already today, a high proportion of the world oil demand goes into chemical production. And by 2030, that is expected to be as much as 1/3 of the oil demand. And we also know that by volume, chemicals on the market, 62% of the chemicals on the European market are classified as hazardous to human health and the environment. And that is by volume. If talking by numbers, the number is even higher. So there is something here that we need to control and to better understand as well, to avoid problems for health and to avoid environmental issues. And there is a political will to do this, certainly, but there is a long way to go. So we can take the next slide. So why is this important in a circular economy? Because the chemicals follow the materials, they are added to materials or they are part of the materials. And when we reuse that material or recycle it into new products, the chemicals follow along. And that means that materials may be used in ways that it was not intended to be used from the start. It can be used in parts of the world where it was not produced. It can be used many years after it was initially produced, and substances that are now illegal may turn up as recycled materials. And different product categories also have different chemical regulations. And as a company, of course, you're responsible for assuring that the materials you use don't contain any illegal chemicals. And that makes it very challenging to use recycled material, because you have to be certain that this material doesn't contain any illegal chemicals or chemicals that you don't want to have in your products because of your corporate policy. And that basically limits the market of recycled material today, and thereby halts the transition into a circular economy and into circularity. We can take the next slide. So one thing we have looked upon in this report is chemicals in a circular economy, what chemicals are found in different hazardous materials and so forth. And today I just wanted to show you two graphs, and you don't need to understand everything here if you find it complicated. But this is from a study where they investigated recycling of paper and how chemicals accumulated over time, and what happened when chemicals were removed from the system. And what could be seen is that looking at some model chemicals here, as long as they were in the system, the levels of these would increase over time up till a steady state, and that it would take 25 to 45 years before that stage was reached. So all along, the levels of these chemicals increased in the recycled materials. And the other thing they did was also to look into different options to reduce the amounts of chemicals in the recycled materials. And the most drastical there, of course, was to limit the input in new materials entirely. And even after doing so, it took 15 years before the levels dropped beyond the detection levels. So these are quite long time spans we talk about when we discuss these issues. And that is also why it's urgent to act sooner rather than later. So we can take the next one. In this report, we have focused on two different material streams. And we chose two different streams that are materials that are very present in our everyday life, and also materials that are have a quite short lifespan before becoming waste. It's also two materials that uses very much chemicals in the production, chemicals intensive production, and also where production has increased very much lately and is expected to increase also in the future. So one of these are plastic packaging. We have a huge production globally and also in the EU, and 40% of plastics in total goes into packaging. And this is expected to double by 2040. That is the plastic production. And even though this is a material and a category of products that has been targeted for recycling for decades now, the levels are still very low, with about 10% being recycled globally. And as I said, this is also a material that is associated with many chemicals. We have, for example, phthalates, bisphenol, heavy metals, different UV filters, surfactants, and a long list of actually about 4,000 chemicals that are associated with the production of plastic packaging, and that can also be found into the packaging. And that needs to be considered when you recycle this into new materials. And we can take the next slide. The other material we looked more into depth in is textile. And I've learned when writing this report what I didn't know, that we actually use about 4 times more clothes and garments now than what we did 20 years ago. And this is also steadily increasing. And we throw away quite a lot of textiles, about 11 kilos in the EU and 36 in the US per person each year. And of this, less than 1% is recycled into new clothes. The recycling systems and methodologies for textile is still in its infancy, and it's very much remaining to be done there. This is also a chemical intensive production where chemicals are added to give different properties to the materials. And we find, for example, alkyl phenols, PFASs, flame retardants, organotins, phthalates, heavy metals in textiles. So we can take the next one. And of course, you can wonder, why are recycling levels still so low when this talk about recycling and circular economy has been there for a long time, and the incentives has been partly there as well? Well, there are many different reasons for this, of course. One is if there is a lack of infrastructure, that means collection of the waste, transport and sorting of the waste into recycling facilities. There are also technical difficulties with a number of materials, for example, multi-layer plastic packaging or textiles consisting of different fiber types. Also, the cost of virgin material has been very low. So for example, the oil price has been very low for a long time now. And that also makes it difficult for recycled material to compete with this low price. It can also be difficult for a company, if you're a large company and wanting to use recycled materials, to find enough quantity in good enough quality from the same supplier as it looks like now. And that is also challenging. But then again, it is this topic that is the topic of today, that as long as there is an uncertainty of the chemical content, it will be difficult to sell recycled materials. And you can come around that by, for example, doing testing, but that is also expensive. So adding to the price of recycled materials. So we can take the next slide. We have also in this report looked into different methodologies for recycling. And the main recycling technology today, and we believe also in the foreseeable future, is so-called mechanical recycling. And this is where materials is made into smaller pieces, shredded or grinded. This is true for both textiles and plastics and also other materials. And then these small pellets or pieces of cloth can be melted or spun into new materials. And when you have mechanical recycling, this means that the chemical once added into the material will also come along into the recycled materials. There are some technologies to improve this a little bit for some chemicals, but basically whatever you put into the system will also come out of the system. We have also studied a number of technologies under the umbrella term chemical recycling. And there are some interesting technologies there that might possibly in the future be used to remove hazardous chemicals from some types of recycled materials. However, those techniques are very energy demanding and also expensive and not yet active on a commercial scale. And we believe that also in the future, the main recycling technology will remain the mechanical recycling, because that is the cheapest option and the one that is functioning at scale. So possibly chemical recycling technologies might be used for very specific cases, but the large bulk of materials we use today will need to go into mechanical recycling to be used again. And when we do that, we need to assure that the material we put in is free from hazardous chemical in the long run. We can take the next slide. So one aspect of this, which has also a chapter in the report, is that it's important for recyclers to know what they get into the system, to know what they get out. And right now it's quite difficult to know from waste what's in there. And different technologies are developed and discussed for how to better trace chemical content of material coming into the waste system. And on the picture here is one example of a new such technology where we use a fluorescent molecule in the plastics that will be fluorescent in a certain light. And if the recycler has this light available in their facility, they can see this and they can then go to some database or something to find out what plastics with this fluorescent molecule may contain. And whatever such technique will be available in the future, it's of course necessary that everyone uses the same technique and can understand what goes into this system, and that the information is somewhere available. And what has happened recently is that the European Chemicals Agency, ECHA, has launched a database where companies are to provide information if they have substances of very high concern in their products. And the aim in the long run there is also to facilitate for recyclers to know what they get into the system. But as this is so new, we don't know yet how effective this will be to actually clean circular economy from hazardous materials. And we can take the next slide. So one thing that we did in this report, and that is new, and that we had a whole webinar on 2 weeks ago, is that we wanted to look into what is the financial opportunity if hazardous chemicals would no longer be an issue when it comes to recycled materials. Could we estimate the financial opportunity there? And to do this, we consulted a firm that are expert on this, because these are complicated calculations. And we looked into different scenarios and estimates. So for example, how much material gets recycled today and in 50 years if we do nothing? And how much more recycling could we expect if hazardous chemicals was no longer a problem? And what would be the value, the financial value of that material? Because that was the figure we in the end wanted. And we can take the next slide. So we tried to do this for both plastic packaging and textile. What was obvious quite early was that for textiles, the recycling industry is so immature, so that the figures available were very uncertain, and we decided to not go through with a full analysis. For plastic packaging, much more data was available, but there is still a lack of all kinds of figures. So it would be very interesting to redo these analyses with hopefully availability to more data. So we looked into different scenarios, estimating if we could recycle 5% more, 50% more, 30% more, if chemicals were no longer an issue, hazardous chemicals were no longer an issue, what would be the value of that material? And of course, this is an estimate, and there are a number of different assumptions, but we could still see that even with only a small increase, this is quite a lot of money to be realized. And the more we can do, of course, the more profit, or the bigger the opportunity is. So I think this is really an incentive for all stakeholders to act now, so that we can realize this opportunity in the future. Next slide, please. So to conclude, what we found in the report is that we see that right now, we see an increased use of virgin materials still, and we see low levels of recycling. And we know that chemicals of concern in materials is an important reason for why recycling has not been scaled up more. We know that mechanical recycling will be the main recycling technology for the foreseeable future, as it is now. And therefore, it's crucial to establish non-toxic waste streams to be able to scale up circular economy and scale up use of recycled materials. And if we can do that, there is also a substantial market opportunity to be realized through the increased usability of recycled materials. And by that, I want to hand over to Teresa to talk more about what this could mean for different stakeholders.
Great. Thank you, Anna, so much. And I'd like to start with recapping a bit why we care about this topic, why we did this report, and why we think it's an important discussion to have. So when these discussions started to take place in the EU, nobody talked about chemicals. And we're used to that because chemicals is considered complicated. People become a bit intimidated. It's a hard topic to take on. But the chemists working for the brands, they realized it. They said, it always comes down to the chemicals. What can we accept? So parts of industry opposes to regulate this area further. I think it will put obstacles in the way of increasing the use of recycled material. But I tend to see it differently. I think that a circular economy and tough chemicals regulation must go hand in hand. They should boost each other and make each other stronger. And only then can we reach a true and successful circular economy. You can switch slides, please. So what we've seen is a lack of communication in this field. So we have the policymakers, the chemical producers, manufacturing processes, the brands, retailers, consumers, waste collectors, and recyclers. I hope I didn't miss anyone. And then it goes round again. And without involving all the stakeholders taking action in each step, there is no solving this. And therefore, we have taken on the task to bridge the gap between brands and recyclers. We've organized a number of workshops discussing the topic of chemical content in recycled material for different product categories, textile and plastic packaging being two of them. We've gathered the frontrunners, global giants, innovative startups from the brands and the recycling side to take a step in the right directions. So I'd like to talk about the outcomes from the workshops, and I would summarize it as follows. When it comes to transparency and traceability, there is so much to be done here. And one thing is to address the confidential information thinking from the suppliers. There are ways around this, and hiding behind this argument will not get you future-proof. The second point is that materials need to become less complex. And one way is to aim for monomaterials. Of course, this doesn't work for all products. Another dimension is the many different types of functionalities that some problematic substances give. So do you really need it? Are consumers really requesting it? And here, the use of PFAS, also known as forever chemicals, is the perfect example. Using whitelists of chemicals accepted is something that we see works for many companies. It increases transparency, but it also simplifies communication with complex supply chains, something that we see, for instance, in the textile sector. And collaborations to finding good recycled material, that's something that we see is really working at the moment. And the report also brings up a few examples of this. The last point is that we need equivalent standards for recycled and virgin material, or brands will not want to use it. So this work that we've done that links very well to the key findings of the report that Anna just took you through. And we have concluded a few recommendations for brands, for recyclers, and for policymakers that our analysis have shown to be success factors. And you can switch slides, please. So let's start with the brands. The design phase is where to start. If you aim to be sustainable and circular, you need to make sure your products can be recycled in a good way and not just in theory. You need to look at things like multi-layer packaging, at textile blends and other complexities in your materials. So the next point is that it's always easier to avoid using hazardous chemicals to start with than to clean them out in the waste phase. So substitute whenever it's possible. And then you need to find out the chemical composition in your products. And I know that you should know that already, but that's often not reality. So try to find this out and enable this information to follow your product. And get information about the composition of recycled material. Make sure that you know what you buy. You're risking your brand name, so you can't really avoid it. And work with others to establish common industry standards regarding plastic types and additives. It has been done before. It can be done again. Just look at PET in bottles. And collaborate with recyclers, waste collectors, and sometimes also municipalities. Do what works for your product. And then you need to accept that high quality recycled material is more expensive. There will be a higher cost for that. So let's go over to the recyclers. If you switch the slides, please. Great. So using separate waste streams, that has proved to give better knowledge and therefore also higher value for the recycled material. And along with this, avoid mixing waste of known and unknown chemical content to preserve the value of the high quality material, and do not dilute. Try to be transparent about what you know and what you don't know about the material. I also want to encourage you to give feedback to brands. When you find a product that is really problematic and causes you problems in the recycling phase, please go back to them and tell them about it so they can change the design. And as already said, establishing close collaboration with producers and brands that can give you possibilities to tailor the process and increase your profits. So my last advice is to be prepared for increased demand and stricter regulation for recycled material. If we move on to the policymakers on the next slide, please. Great. I mean, we know that problematic substances in waste, it's a roadblock for recycling. So therefore, policymakers need to take action to regulate the phase out in a much higher speed than before. In addition, hazardous chemicals must be included when we regulate circular design, sustainable products, and other initiatives. If recycled material is to be used by brands to a large extent, regulation must ensure that the same requirements apply for virgin and recycled material. I cannot stress this enough. Another important aspect here is to regulate the imported articles as well, so that they follow the same regulation, and not approve derogations in chemical regulation. So the next point is about transparency and traceability, and we need to know the chemical content, and we see a lot of progress here, but there's still a long way to go. I also want to emphasize that the recycling phase of products and material must be included and considered in all socioeconomic and impact assessments. This is currently not the case, and neglecting to see this angle, it gives a skewed result of the assessments and therefore might also give a different outcome. There needs to be a system in place to reward frontrunners, to balance the cost premium that often comes along with this. And the Commission mentions this reward thinking in its recent chemical strategy. And we encourage this to be ambitious so that we can reach a more level playing field here. And then my final remark is to be careful when it comes to definitions. A so-called recycled good should be made of materials derived from waste. And you should be able to prove a physical link. There's a lot of ongoing work right now that revolves around this. And one very tangible thing that can be done is to introduce definitions of chemical recycling technologies in the EU waste legislation to increase clarity and to exclude fuel production. So the next slide, please. There are some serious hurdles, but as we have seen, also great opportunities with addressing the chemical composition of products in the initial design and production phase, as well as when the product becomes waste. Waste is becoming a resource, but only if we treat it as such, if we are respectful at every stage of the life cycle. So the first adopters will, as always, be the ones coming out of this transition best. And there is no doubt we are going towards circularity because we have to. So this is the end of our presentation, and we're going into a Q&A section. And I wonder if Peter, if you could help us with looking at the questions that have come in and select a few important ones. See if we can give you some relevant answers.
So, we have many questions, and I know some of you have written in the chat box, but please post the questions in the Q&A box so we can keep track of them. And we will try to manage and answer as many as possible. So many good questions. Louise asks, are chemicals the major obstacle for recycling, or are there other lower hanging fruits to increase circularity?
Should I take that, Anna, you think? Okay. Well, to be real honest, that's for someone else to answer. We are not the experts on every field of circular economy. I wish I were, but I'm not. We are experts in the field of chemicals. And I know, for instance, when it comes to textiles, that the most efficient thing you can do is to use the garment as long as possible to prolong the lifespan of it. But really, this is a question for someone else, and I will be humble enough not to answer more than that.
Are there any data for metal packaging recycling available? Do we know?
I think there is data. We did not look into that specifically in this report. I know there was a report coming out end of the year that actually also looked at the financial aspects of this. The references in the report, I cannot right now remember what it was, who did that one. But there was something there on metal and glass and something more that was interesting.
Okay. So here's a phthalate question where someone says that Exxon has paid millions to ask the US EPA to do a priority review of the phthalates DIDP and DINP under TESCA. So these chemicals are on the sin list, obviously, and they are already used to make many plastic products. However, they are not on a typical analytical testing list. Therefore, we don't know if they are being omitted from industrial air emissions, causing health effects in communities around manufacturing plants. As a global community, we have to keep these chemicals out of the waste stream in the first place. How do we mount an effort to oppose things like this in the US and change the process in the US? So, yeah, good question, quite substantial.
Yes, quite a substantial question. We work mainly to change with the policy processes in the EU, and therefore I have difficulties to answer exactly how you could influence the process in the US. What I can say is that I know that there are a number of independent academic studies on these phthalates, possibly leakages and health effects and all of that. So it's not necessary to await these testings from the governments and the agencies. Then in the end, of course, these are the ones that need to take a decision on regulation. And my only recommendation would be perhaps to also get more in contact with the US NGOs that work more on addressing policy in the US.
I think we also know that in general that it's more state-driven rather than the federation in the US, and also that brands are doing a lot on their own in the US as compared to the EU, where policy is more stringent, right?
Yeah, that's what I would really talk about as well, that we can see that brands are really concerned about things like phthalates in their plastic packaging or other production of products. And this is relevant for the virgin material, but also for the recycled material, of course. If you claim to have phthalate-free packaging, a consumer doesn't really care if it comes intentionally added or not. So I think that we can see a lot of action from companies here. And I think it's a pulling situation where for quite some time now, companies in general, not only in the US, but also in the EU, they've really been pulling this chemical strategy, really. And now policymakers have taken it one step further with the chemical strategy coming into place. So I think it's a combination of efforts, really.
Yeah. So the market projections that we had in the report, Anna, the value of the recycled textile and plastic that we mentioned there, are they estimated based on the available infrastructure in the EU for recycling?
Good question. They are based on a stepwise approach. So both looking into how we projections of how the market is growing for the materials as such, and also how recycling is following on that one. we did the different scenarios and also lowered the projections a bit to what was proposed first, because we also see there is a drive to, for example, decrease plastic packaging, and there are a number of regulatory new incentives in there. Now I almost lost the question. Sorry. If we are looking into new types of research, recycling facilities into the report, I would say not in detail. We're only looking at the large scale projections there.
Can you elaborate on how you think that whitelist could be used in a value chain? Who would ideally establish them? Upstream companies together with regulators, ? Downstream companies tasked with processing and recycling? Or should there be like collaborations across the whole value chain? What do you say, Teresa?
I'd really like to answer that one. Well, we do have examples from several companies where this has proved to be really, really useful, especially because it can be difficult to communicate throughout the supply chain, especially when it's global, and it has multi layers. So this is one thing that we have seen that companies do, but we also see an increased interest from companies to cooperate within specific areas, but also between different industries, to see if there are possibilities to create these whitelists which would simplify this process very much. And I would add to that there has been a lot of discussions in the policy area in Brussels during workshops and other events to streamline and create some kind of whitelist idea about what materials could be used for certain products, but also what additives would be allowed. For instance, take a shampoo bottle. Again, I like the shampoo bottles, clearly. If only a certain type of plastic would be allowed to be used for shampoo bottles and a few limited numbers of additives, then it would be feasible for recyclers to actually make a shampoo bottle into a new shampoo bottle again. As it is right now, that's really not possible.
Okay, but you said that the good quality recycled material, that is more expensive. When do you think it could change so that it becomes the same level or even cheaper?
I think there are two ways to see this. I mean, one is that the demand increases, could go either way, really. It could increase the price even more, which we can see with PET, for instance. Recycled PET can often be more expensive than virgin PET. But also, of course, if recyclers are able to identify waste streams that are controlled in the way that PET is, that would increase their the amount of material that they could produce with known content.
Do you know if recycled clothes can be recycled once again, or is it just like one extra loop that it could be going through?
Anna, would you start there?
I don't think that the problem is if it's clothes or not, but there is a problem on your recycled cotton fibers, for example, that they are becoming more weak. And so therefore a more common way to recycle textile is to recycle it down to insulation or wipes, where you don't need the same fiber strength. So that limits the number of times you can recycle the textile. And that is also true for plastics, actually, that there is a limited number of times you can recycle it to maintain the quality.
And an added complexity with the textiles is, of course, the blends, where you often need to choose which part of the blend you would like to use when you use the fibers. So this is something that industry needs to take a closer look at, I would say.
But if you have the same chemical limits for virgin and recycled content, doesn't that encourage producers and brands to continue favor virgin material?
I absolutely don't think so, actually, because I've seen for a very long time big brands being really ambitious when it comes to circularity, really setting high goals on how much recycled content they are going to have in their products, but they can't find enough material as it is today that fulfills that requirement. So that is really not something that I see. I would say the opposite. Then they could rely on the recycled material and not risk their brand name by risking exposing their customers to unintentionally added substances that are problematic.
Yeah, great. So Tove says here that the majority of textile recyclers, they work with non-profit collectors. How can recyclers test this collected textile material coming from all over the world in the best way? Do ChemSec have any recommendation what we as brands can demand from them?
We have some experience from the workshops that we held. I'm sure many other actors are much more competent to answer this question, but I'll give it a shot anyway. And one big problem is that there is no way to know what material a garment is made of unless you use your hands and your vision today, because often these labels are pulled off and there is no traceability whatsoever. So they hire these skilled people who actually touch the garments to identify what it is and then sort it into different categories, and you have to remove prints, buttons, all of those that cannot be recycled in the same fraction. So I'd start with actually finding a tracing system where you know what the garment consists of or is likely to consist of. Let's start there.
And this is also, I think, one point where brands could actually benefit from stronger regulation, right? Because if you have a stricter chemicals regulation, you won't have these chemicals in the product from the first get-go. So
yeah, we very much talk about design then.
Yeah.
And it could be, right now, if you have this big print on a t-shirt, you have to rip that out. You cannot recycle that. And it's possible that some types of designs will change. And I would say that there is a shift within parts of the textile industry where the chemical content kind of sits above the designing agenda, so that the designer gets a clear box of what they can and cannot do, and not the other way around. And I think that is really key when it comes to getting to this issue.
Yeah. Simona asks, where can we follow the developments of the EU waste chemical regulations? At ChemSec's website? No? Is that a good answer?
That's a good answer.
Yeah. You should subscribe to our newsletter also, Simona. Are we familiar with the concept cradle to cradle? If so, what's the opinion of the concept? Is it a possible solution to some of the questions raised?
We are familiar and we have discussions. We know that they have criteria that are updated now and then for chemical content as well. So yeah, I think that's basically what I'd like to say right now.
But I think they face the same problem, that if it's a recycled material, you have to know the content in order to evaluate it. So, I mean, the main problem is that of information for them and for us.
So did we also analyze materials like leather when we looked at textile, which generally would be really challenging to substitute chemicals like chrome, for example?
We did not go into that detail when looking more at the flows of the materials and the recycling and so forth. And so not for this report. We have looked more at that, for example, in authorization process, and we're discussing hazardous chemicals specifically, like chromium compounds and so forth. But here we looked at the larger strokes and the material flows on a larger level.
Yeah, and I can add to that when it comes to the use of chemicals and in these types of processes, like Anna said, we engage very much in, for instance, the authorization procedure. Now it becomes very technical, but you can say that, for instance, chromium, you can only use that if you have been admitted to use it via an authorization. And here we very much are for not giving derogations from this. For instance, if there is a way to treat the leather or the wool or whatever you talk about that is technically available, you should not grant authorizations for continued use of hazardous substances when it's no longer necessary.
And I just want to say also that we have the marketplace that Teresa introduced in the beginning as one of our tools, where companies can advertise if they have alternatives to hazardous chemicals. And we have quite a lot of textile products in there.
Especially substitution for chrome as well. I think we have a couple of them as well, solutions. So you state that mechanical recycling, it remains the number one. However, mechanical recycling has the drawback that one can only recycle a few times due to the quality losses. How did you incorporate this effect into your financial prospect?
We did not do that specifically into the financial process. When we looked at the different technologies for recycling, we looked also at that aspect when comparing, and that is sometimes also the case for chemical recycling. So I don't see that we can get around that, but that is rather an inherent, yeah, that's how recycling works right now. Mm. And you will need to blend in virgin materials, for example, to raise the quality.
Is blacklisting hazardous chemicals the most efficient way to phase them out? What are the major obstacles to that?
Oh, clearly it is. There is the problem of regrettable substitution. When blacklisting, which is the way we have done it so far, I think we have to look at it more as a group-wise approach, especially when we talk about problematic groups such as the PFAS group. You can't regulate one and then you have 5,000 more. I would say that blacklisting has been most common for a very long time, but that whitelisting is a very easy way to target it, but it takes a lot of work to be able to make that list thoroughly and update it as well. So I don't know, Anna, if you have something to add to that.
And the only thing I can add is that what we call white lists are more product specific. So it's not listing every chemical in the world that is not hazardous, but it's rather going into what additives to use in a specific process that is approved for that application. While a white list listing the most hazardous chemicals based on their intrinsic properties, did I say blacklist? Yes, is much more universal and then applicable for all products. I also saw in the questions that there was a critique for us using the words blacklist and whitelist, and that is a bit unmodern. I think for us right now, that's simply because people understand that wording. Of course, you can call it many different things. We call it the sin list for our blacklist, and we call it the marketplace for our whitelist. So it's basically a way to speak that most people understand.
Yeah, but when articles were made with the DEHP and BPA in the 70s and 80s, legislation of the day, it stated that they were safe. So in 2050, substances used today that are considered safe may be by then shown to possess a new and currently unknown hazard. Is the solution to never recycle, or to recycle the best risk assessments, or to recycle using the best risk assessments we have with substance tracking?
Well, I think this is a very complex question without a simple answer. I mean, the things that we have been producing and consuming plastic in an unsustainable way for decades. So we're left with more or less problematic waste in landfills floating around in the oceans. So it's a problem not only for human health and the environment, but also for brands and the plastic producers. So we need to change our ways. We need to stop this as far as we can. And then we need to look at the legacy waste in a different way than the new waste, especially when we talk about things like plastic packaging. It has a very short shelf life. So there, I think we are able to make changes faster. We're not usually finding the plastic packaging dating 50 years ago when it comes to these types of products. So I think we need to look at different categories a bit differently.
And I can add to that also that I think alternatives assessment is key. So whenever replacing something, to investigate that thoroughly first to avoid this, what is called regrettable substitution. But then I realized that we will not be able to predict everything because science is developing. So there will be a need to continuously fill these blacklists, so to say, and also adapt the whitelists. And that will be a continuous challenge to recycling. And there, information and transparency is key. This is also how some industry works, for example, construction industry, where you know that a building will be there for 50 to 100 years, where more responsible and sustainable companies clearly list all the materials going into that and all the chemicals going into that, so that even things that are not restricted or banned today can be traced in the future to understand when you demolish that building and use it again, if there is a chemical of concern by that time in 100 years from now. So more transparency of what goes into the products is definitely needed to future-proof this.
So following that, how can transparency be increased between suppliers and recyclers so they don't rely on analytics, but they know what's actually inside? So going further than skip a database. In Cradle to Cradle certification, we know what is inside, but we're bound by non-disclosure agreements.
There are definitely ways around this. And also the main importance is very seldom to know if it's 10 or 12 or 15% of one specific ingredient. And this is something that we've seen made possible in the US, actually, where they've come a bit further when it comes to disclosing fragrances in some household cleaning products, where they look at it to disclose it. They disclose the chemicals, but not the ratio. So there are ways to come around this. I really think you need to be creative, but when legislation is in place, like we saw then in some states in the US, the possibilities are there. They find solutions, absolutely.
Okay, so we are approaching the end here. And before you say goodbye to us, I just want to add to everyone that sorry if we couldn't have time to answer your question. You can always send us an email. And I really advise you to follow us on LinkedIn or Twitter, where we always put out, topics, content around topics like this, or subscribe to our newsletter, where we always discuss these kind of things. So if you're interested, you should follow us there. And maybe Teresa, you want to close saying something?
Yeah, just thank you everyone for attending. And it was really interesting to see so many questions. We will definitely have a look at them and see if we can answer them in some other way, maybe a Q&A on our website, something like that. And as Peter said, please subscribe to our newsletter. Then you will have information about upcoming webinars like this, if you found this useful, but also other events. So thank you so much.
And also the $1 million question, the slides and the video, will they be available after the presentation? Yes, they will be.
So thank you so much for today.
Yeah.
Okay, have a good afternoon. Bye.
Bye-bye.